Okay, today's lesson we're going to talk about scatter plots. And actually in 8th grade math you would have learned lots and lots of stuff about scatter plots, but y'all skipped that grade. So a scatter plot, in a very quick summary, is a graph where you're trying to see if information is related. Okay, so for example, if I own a snow cone shop and I want to know if the temperature outside has anything to do with my sales, what do y'all think? Snow cones and temperature. When do people usually buy more snow cones? Okay, so let's say I wanted to test my theory. I would take a graph, or I would take my data, and I would say, okay, today the high was 105 and I sold 500 snow cones. The next day it was 100 and I sold this many, and I just kept keeping all that data for the year. And I graphed it. If it looks like this, do you see how all these dots are moving in the same direction and they're kind of clumped together? This is like as the temperature goes up, my snow cone sales are also going up. So I would say, hey, this data is related and it's a positive trend because as temperature goes up, sales go up. So right here, guys, and they don't make a straight line, but it's making a straight line pattern. Does that make sense? So we call this positive linear. And again, that's not a straight line, but it's going in a straight line pattern. Okay, this next one. Let's say I, as a teacher, I want to know if your height is related to your grade in my classroom. So I take all of your heights and I write them down, and then I take your grade in my classroom and I graph it and it looks like this. What do y'all think? They have nothing to do with each other. This is called no correlation, or you could say no association. Meaning the two pieces of data I'm comparing, they don't matter. They have nothing to do with each other. Okay, this last one. Let's say I own a snow ski rental shop, and I want to know if the temperature outside has anything to do with my snow ski rentals. So what do y'all think? As the temperature goes up and it starts to get hot outside, what's going to happen with my snow ski rentals? They're going to go down because the snow's melting, right? So it's related, but it's moving in what kind of association? This is a negative linear association. So do y'all understand why we use scatter plots? Yes or no? We use them to see if two sets of data are related. Okay, and then how are they related? Are they moving positively? Are they moving negatively? Are they nothing to do with each other? All right, so let's learn how to make a scatter plot. So this table is based off of the length of fish and how fast they swim. So right here is the length, and over here is their speed. Thank you. So what you're going to do is you're going to go graph these points. Now when you graph scatter plots, put them in the best spot. So on the length, I'm going to go to 37.8, which is going to be somewhere in here, and go up to 148, which is going to be somewhere near 150, and you're just going to put a bunch of dots. So everybody go graph it. Okay, you should have 5 dots on your graph, and they should look pretty close to mine. Yes? So, what are y'all noticing? As a fish gets longer in length, they're tending to do what? They're tending to swim a little bit faster. So it says describe the correlation. It is what kind? It's going up. It's positive. It is moving in a somewhat of a linear path. And another way to describe this is as length increases, so everybody look, as length increases, speed does what? Speed tends to increase. Yes.
It's not supposed to say speed or
The speed. Thank you. Okay, so let's turn the page. This next one that we're looking at says the table shows the number of active red woodpecker clusters in DeSoto National Forest in Mississippi. Now, for some reason, this graph is labeled wrong, so we're going to have to fix it. We are comparing the year to how many active clusters of these birds there are. So on the x-axis, it's years since 2005. So if you would, just mark those numbers out. You don't have to have white out like me. So this would be 0. This would be 2005. Yes. This would be 1 year since 2005. 2 years, 3 years, 4, and so forth. And the reason I know that is because they put years since 2005. They told me that's how they want it labeled. Yes? And on the y-axis, what are we going to put? Our active clusters. So let's talk about this up here. Since it says years since 2005, 2005 would be the start, yes? So it would be year 0. What would this be? 1, and then go down the line. This is 2 years since 2005, 3 years since 2005. Does that make sense? Yes or no? Okay. So it wants us to make a scatter plot out of this. So go graph it. Again, you're not using the years. You're using 0 and 1 and whatever. So 0, 22. Okay, so it says describe the correlation of the data. So what is this data doing? Is it related? As the years are going up, what's happening? There's the active clusters are increasing. So how would I describe that? Positive, negative, or no association? Positive. So it's a positive correlation. As years increase, active clusters increase. Now look at this next part. It wants you to write an equation of the line of best fit. A line of best fit is a line that you could draw through those dots that don't touch all the dots. They go through the middle of the pattern. Does that make sense? So basically, if I was to take a ruler, I'm kind of just looking for the best path that these lines are following. And y'all don't have to draw it. We're going to write an equation. I'm just kind of showing you that the line would kind of look like that. See how it's just kind of following the pattern? Yes? Now, your calculator will write an equation for you of a line of best fit. So, right here in this little box, let's write how we're going to do that, and y'all already know how to use this button. We're going to go to Stat, and we're going to go to Edit, just like we always do. And for L1, we're going to put our X's, and for L2, we're going to put our Y's. And then you're going to go to Stat Calc, like we always do. And then you're going to go to option 4, because our line of best fit is linear. Yes? It's following a linear pattern. So you're going to do option 4, and then you're going to write your equation in y equals mx plus b with the numbers that it gives you. Okay, so get your calculator. You've got your data right here. But are we going to use 2005 for x or 0? 0. Okay, so go to Stat Edit. So my L1, I'm going to put in, and guys, I need you to listen carefully. You have to put in every single piece of data, because this is not a straight line. All these dots are like all over the place, right? Your calculator is calculating a line of best fit based on all of this information. You have to put in every single piece. So once you have all your data in, you go to Stat Calc, option 4, hit enter, and it's going to calculate your line of best fit. Now again, this is not a perfect line going through these dots. It's called a line of best fit. So our equation would be y equals 3.7x plus, and let's round to the tenths place, 19.9. So my line of best fit was off a little bit, because look how I put my line. It's going through that dot at 22. This is saying it should have passed at 19.9, more almost like at 20. This is super accurate for line of best fit. This was just me just freehanding it. Now, what if they ask you to make a prediction based on this information? So I forgot to type this, so we're going to write it down. Right here, I want you to write how many woodpecker clusters would there be today? How many woodpecker clusters would there be today based off of this information? You do not get to guess. You have to use the equation of the line of best fit. Okay, so let's talk about it. First of all, we need to know what is today. Today we're in what year? So we're in 2023. So what is our x-axis talking about? Years since. So how long ago was 2005? 18 years from 2005. So what would I plug in this 18 for? The x, because x represents what? Years since 2005. So I take this equation. So I take y equals 3.7x plus 19.9, and I plug this 18 in for that x. And it will tell me how many woodpecker clusters based on this pattern there should be today. So I just go to my calculator and I type in 3.7 times 18 plus 19.9, and there should be about 86.5 woodpecker clusters. So I'm going to say it again. We used the data that was taken and we graphed a scatter plot. Y'all are all good with that? Yes? Mm-hmm. How did we get our equation? Stat, and then we wrote our equation of best fit. Then we can use that equation to make predictions by plugging in for X or Y based off of what they ask. Okay? Any questions on what we did there? No? All right, let's go down to the bottom. It wants you to write an equation for the line of best fit and then draw a line of best fit. So the easiest way to do this is to have the calculator do it for you. But to put it in stat, I have to make a what? I got to make a table of these values. All right, let's start with the first dot. Where am I at on the x-axis? -1. Where am I at on the y-axis? -4. This next dot right here, where am I at on the x-axis? 0. Where am I at on the y-axis? -2.5. Okay, this next dot, where am I approximately on the x-axis? 0.5. Where am I at on the y-axis? I would just round it to -1.5. Okay, this one I am at 1. Do I have to do all of them? Yes. On this one, where am I on the x-axis? On the x-axis, 1.5. On the y-axis, 2.5. And then this last one, on the x-axis, I'm at 2. Now this one, I don't think I would round it to 0.5. I'm like at 4.1 or 4.2. So what do y'all want to put? 4.2? All right, so where am I going to go to get an equation? Stat, edit. Now, just so y'all know, if you want to clear out your whole list, you can go up to L2. Do not hit delete. It will delete the L2. Hit clear, and then just tab down, and it will clear out your list. Okay, then go put in your data. Now what do I do? Stat calc, option 4, because we're looking for a linear line of best fit. And my equation, let's round to the tenths place. So y equals, how would you round this? 2.8x plus, minus 1.9. Yes? And then you could draw that graph on that line on here if you wanted to by going to y equals, typing it in, but we're good. All right, let's do this one. Make a table. Okay, what's my first x value right here? -3. The y value is 1. Okay, I'm going to go to this one. I am now at -2, +3. It doesn't matter what order you put it in.
At 0, -1.5, is that dot?
No, that's just the arrow, I think. No, it is. I can't tell.
It looks like the other arrow.
I think it's the other arrow. -1, 2. 0, 4, 1, 6, and 2, 7. That one was easier. All right, let's go put it in our calculator. Now, hey, everybody's eyes on the board real quick. Everybody look. If I go up to L2 and I hit delete, watch what happened. It deleted my list. My calculator's stat button will no longer work. To restore the list, you go to stat and go to setup editor 5 and just hit enter, and it will restore it for you. See? Okay, so just in case you accidentally mess that up. Okay, do we need to do this last one, or y'all got the hang of it? Got it? Okay, and you can use this to make predictions. Like they could say, based off of this information, what would y be if x was 10? So you would just go plug in 10 for x and say, what would y probably be? Make sense? Okay, on this last page, I basically put 2 lessons in one because this is so easy. I need to talk to you about a correlation coefficient and how to tell if a trend is weak or strong. So just real quick, jump down here. Do y'all see how these dots, if you connect them, they make a perfect line? That's called a strong correlation. Okay? Do y'all see how these dots are all spread out? That's no correlation at all. Yes? Okay, y'all don't have to turn the page, but look at these dots. Do you see how they are going down? It is a negative association, but they're not like stacked on top of each other. That is a weaker correlation because they're kind of spread out. Yes? This right here was a pretty weak correlation because they're kind of spread out, but it was positive. So when you're talking about how correlated is it? How positive is it? Is it strong positive or is it weak positive? This is called a correlation coefficient. It is denoted by R. It is a measure of the strength of the linear equation or linear relationship. So when we use stat, and y'all don't do it, do you see how it just gave you A and B? Okay? I want you to write this down at the top. To get to the correlation coefficient, you have to go to second catalog. And then from there, you have to scroll down and turn your diagnostics on. So we're going to leave the data that we just put in. Everybody still has this data in, right? I want you to find catalog above 0. So hit second catalog. And you're going to scroll down, just hold the down arrow until you get to the D's and find diagnostic on. Did y'all find it? Everybody's there or no? You're going to, once you're at diagnostics on, do I need to wait for somebody? Okay, hit enter. And then hit enter again, and it should say done. Once it says done, you have now turned your diagnostics on in your calculator. Now go back to stat. Make sure go to edit, your information's there, yes? Now go to stat calc option 4 and hit enter all the way down, and look what happened now. They gave you, is that the same answer we had a minute ago? Yes? But they gave you an R. Do y'all see the R? Don't look at the R squared. I don't even know what that is. I only know the R. The R is the correlation coefficient. If the R is really, really close to the number 1, so do y'all see how this is like 0.94? That's really close to 1, like 100%. Yes? Then it is a strong correlation. If I was to graph it, those dots would be really close together. like this. If you get a perfect 1, it is straight up linear. If it's close to 1, it is strong positive. If it's close to -1, it's strong negative. So does everybody see this? So if it asks me, is it strong or weak? You just go to diagnostics on and look at the R. If it's close to 1, it's strong. If it's not close to 1, like if it's 0.7, that's weak. Make sense? Yes or no? Okay. So it says, how can you tell if it's weak or strong? When R is near 1 or -1, the linear relationship is strong. And again, the closer it is, if it's to +1, that's positive strong. To -1, that's negative strong. Yes? When R is near 0, like 0.2, 0.4, 0.5, that is a weak association. Does this make sense? Question?
So if it's closer to 0, it's weak, and if it's closer
Yes.
to 1,
I mean, the only time I've ever seen this asked, it was like 0.9, and it's strong. If you graph it, you would see like where it's at. Like this is a positive, but it's not a very strong positive because they're kind of spread out. Okay, now on your assignment today, there's no questions over this, but there have been a random question on the EOC. So I want to go over it with you. It's pretty common sense, but we still need to talk about it. Does that make sense? Yes or no? There is a difference between correlation and causation. Listen to the vocabulary words. Correlation means there is statistical evidence that show they're related. For example, the temperature outside and my snow cone cells. It's correlated. Yes? Causation means that a change in one variable will, no matter what, it's going to change the other variable. It has to happen. It will cause it. Does that make sense? Causation means if I change this variable, for example, if I turn the heat up on a burner to a certain degree, it will cause my water to boil. That is causation. That is not correlated. Okay? Everybody good? So let's do some examples and let's choose if it's correlation, causation, and then there's a trick one where there's none. All right, y'all ready? The number of snowy days and the number of hot chocolates sold. Do you think it's correlated, like it has something to do with each other, or do you think it will absolutely cause something? It's correlated. It will probably happen, right? All right. Number 2, the number of minutes a furnace runs and the temperature of the house. Do y'all know what a furnace is? A heater. So do you think the number of minutes I turn my furnace, my heater on, will it correlate and most likely heat up the house, or will it definitely heat up the house? Definitely. So which one is that? That is going to cause 100% for my temperature to increase. Number 3, the number of miles driven and the amount of gas used. Y'all pick. Don't say it. Let's see what you pick. Is it just related, or is it causation? It's going to happen. I'm only hearing one person. It's going to happen. The more miles I drive, what's going to happen? I'm going to have to use up my gas. That is causation. Let's see what you think about number 4. This is kind of a trick question. The age of a child and the length of their hair. This is a trick question. What do y'all think? It's a trick question. None. Because what if you cut it? Right? Most little boys get their what? Most little boys get their hair cut. So if I'm doing that on boys, it's really not going to be great. A lot of little girls get their hair cut. So it's kind of not related. Now, if you took out the variable of cutting hair, then yeah, that's going to be causation. The older a child, their hair is going to grow. But you have that variable of cutting it, so it's kind of not related. All right, number 5. The number of cars on the highway during a holiday weekend and the number of traffic accidents. What do y'all think? Correlation. It is not 100% going to cause an accident, but the odds are high. Okay? Last one, number 6, the number of minutes a person spends exercising and their body weight. Correlation. It's not going to 100% cause them to be a certain body weight, okay? But it is correlated. All right, let me get you your assignment. I do need to explain because we're going to add in some of those correlation coefficients, okay? Okay, let's look at your assignment. On 1 through 6, you are simply going to say, is it positive correlation, negative correlation, or no correlation? Okay, any questions on that part? Yes or no? Nope, just positive, negative, or none. Okay? On 7 through 12, it wants you to, and I only want you to write the equation of the line of best fit. I'm not going to judge you on your drawing, so you don't have to do that part. I want you to write an equation. Are our answers going to match 100%? No. Okay, because some of them are decimals. So you're going to have to make a table out to the side. You're going to have to put every single one of these. Yes? And then you're going to write an equation. You could do it like right at the bottom. Everybody good? Okay, flip to the back. Now our answers should match 100% because they are giving us the what? They're giving us the data. They want you to make a scatter plot. They want you to draw a line of best fit. So everybody listen, you're going to do both things here. You're going to make a scatter plot, you're going to draw a line of fit, and you're going to write an equation of the line. I do want you to round to the tenths. Okay, so real quick, at the top, I want you to put round to the tenths place. That's 1 decimal place. Are you going to draw a line through the dots of best fit? Yes. Okay, then the last question is super easy. Don't skip it. You're going to make your scatter plot. Talking about years since 1997, draw a line of fit, write an equation for the line, and I want you to put part D. What is the correlation coefficient? Y'all know what I'm asking for? The R. The R. So if you want to put that in parentheses, the R. The diagnostics are on. If you don't turn them off, they're always going to be on. So right now, it'll work for you every single time. Okay? All right, you can get busy.